I just wanted to emphasize the importance of optimization levels in this project of CREPL. Now, because we are using the GCC compiler, we cannot improve the compiler compile times because, I mean, isn't it obvious? The only way to improve it is to keep tabs on your optimization levels. And why is it so crucial for this project is because each instruction or line, or I don't know, block of code, be it a function definition or function declaration or expression or function call, but a function call or expressions, they need one main eval compilation, which is here. Which is there. Let me just check that. Transform function call. Yeah, so function call and similar expressions would take one compilation of the main eval. But when you have a declaration of any kind or a definition, it will take your variable and allocate it onto the respective shared library, because we need to keep it in the current program address space. And we need the main eval to add the runtime entry. So that's why it is so crucial. We don't want the experience on the user experience of the REPL to be, sluggish, to be slow and not smooth. And I mean, I noticed this when I was including the entire stbds file, and I needed to remove all of the hash table implementation because it was really taking a toll on the performance and the experience of the REPL. And REPL should execute each instruction pretty fast. Or at least to a point where it is not noticeable by the user. So if I take the entire file of stbds, let me just fetch it. So if I take the entire file, now you can sort of reduce, the code size of your respective libraries, or you can just dynamically link them. But a problem with something like, but a problem with a header of stbds is the fact that you can see that we are using macros for array push, array capacity, set capacity, array get length. So you can't really use that as you can't really use it dynamically. So you cannot dynamically link those. You can only use it statically. So if I take the original file, which will be, so this one was about 700 lines, but the original one is about 2000 or 1900. And now we can see this significant impact on the performance of the compilation times So it's really, really slow, and we have to ensure that compilation times are as fast as possible in the REPL project for the reasons that I outlined and highlighted in the beginning. Because each instruction or each code block, whether that is actually, if it's a definition or declaration, it will take two compilations. If it's expression, um, it will take one compilation. But either way, we should make sure that is as fast as possible. So let's say our CREPL project really scales and we will end up with headers that are very large. And let's say that if we scale out and we end up like with headers like I don't know, 2000 lines and stuff like that, like STPDS, and what then? Well, the only improvement we can make is, and I've seen this diagram also online where, let me just pull it out. Well, you can clearly see how, I mean, obviously, I mean, O3 is good for, I mean, it makes your code a lot faster at runtime, make no mistake about it. But the problem is we don't need that for the CREPL project. We just want to enable people to run commands at runtime. And why would we need O3 optimizations really if we are only just using it for static code analysis? For example, I don't know, to detect some additional code checks where if you want to check for uninitialized values. I mean, O3 is really great for advanced static analysis in terms of to give you a warning or an error if you're treating it as error, to give you a heads up if your code is likely to result in undefined behavior. So if I pull out that diagram real quick, we can see that it takes about this many, I don't know if this is seconds or milliseconds, but either way, the impact on compilation times is like 500%, something along those lines. So if we are not really concerned about our runtime performance, I'll just do this. And let's see if it's as noticeable as it was, I mean the compilation times, as it was with the O3. So clearly it is not, it is faster. I haven't exactly, or is this the make file? Okay. Or I haven't exactly benchmarked this, but either way, we can see it. Let's revert it back to O3. Oh, it's heaven and earth. I mean, I need about, let's say, 1, 2, 3, 4. Oh, let me just make sure I'm just running the compilation, shall we? So what do I need? This clean main eval app. So that's gonna be make test 1, 2, 3, about 3 seconds. Let's round it up to 3 seconds. And with O optimizations, 1 second. So we are much faster, and I mean, what's there to say? even this looks a little bit slow for a project like CREPL. I mean, in these situations, we can ensure that we use the dynamic link libraries, um, as opposed to something like if our code really scales out. But if it really scales out to the point we are using something like I mean STBDS, but still, if we are concerned with our compilation times in this project, we are just gonna go with dynamic link libraries. It is what it is, and it will increase our compilation times. I mean, you wouldn't even have to even worry if it's 01, if it's 00 or 03. Really, it's just, it will take care of itself. But then we need to change our code implementation, because now we're not using the STBDS, and you're not using its macros. But if I go to the previous point where you reduce your library to, I don't know, 600 lines, only use the stuff that you need to use. Now, clearly, the significance is, I mean, out of this world, or rather, the trade-off you can get is out of this world. If you don't want to use that piece of code, I mean, why would it be there? So yeah, that would be my approach and my advice towards this. But if you have no clue what I'm talking about, you need to go back and watch an introduction to CREPL video, and you'll know where I'm coming from and what's the background / context for this. And I'll just run the REPL real quick to show you. So it's gonna be test prompt. So yeah, what I was talking about is each line will, let's say it's a declaration, we need to an integer. Yeah, of course. So this is a declaration, and it will take two files. It will be in lib A. So now that we can load it in the current virtual address space memory of the program, and we can refer to it by DL sum, and of course this all just stays persistent and alive in the currently running program. So yeah, I actually haven't tried an assert call here, but I'm sure my REPL is gonna break. It shouldn't break here though. Yeah, that's all good. That's great. Why did it add that? Oh yeah, of course. Assert, but this is gonna break for sure. Yeah, this is not gonna be easy to cover because you don't have try and catch in C really. But I guess we can, we can implement our own assert where we don't exit out of program. We're just printing out, okay, that assertion failed. But then we'll really, I don't know, playing games with the implementation of assert in C, but yeah, this use case is specific, so I guess you can get away with that. Yeah. All right. Anyway, that'd be all for today. This was a really casual video. I just am talking about this stuff really off the top of my head. It would be like a, yeah, like s- streaming some coding or programming, but what I also wanted to show while I'm uh, running those commands in REPL is I like to make sure that I show what GCC commands I'm executing, so it's easier to grasp what I'm saying here. So since there are two files, like I said, for declaration and definition, first we need to compile that, and then we compile the other one. So it's gonna be in total, but if you think about it, it's actually two commands. Uh, Technically, I mean, it's four, but let's say it's one compilation per file. It will be four, but it's just we're linking it. So yeah, that's how it works, and that's why I'm talking about you know the optimization levels and what can we really do about them, and what's our approach or solution to that, or alternative, like using a dynamic link library. So yeah, it just really depends on your project, and yeah, it would fit, and it would be suitable for this one, since we don't really matter about, I mean, we don't really care about optimizing the code, and at runtime we just gotta make it run. It's a REPL. So yeah, it is what it is. Anyway, thank you for watching, and yeah, it's been a pleasure, and until next time, take care.